I am Himaja. I am doing my MTech in VIT AP. Today, I would like to discuss about SPI Communication Protocol. SPI means Serial Peripheral Interface. The Serial Peripheral Interface bus, it is a synchronous communication, whereas if we go to UART, it is asynchronous. SPI is synchronous. So it is used for short distance communication. The interface was developed by Motorola in 1980s. So it is used from 1980s itself. Here the communication takes place in full duplex mode, that is from master at a time and from slave at a time. The master device originates the frame for reading and writing. Multiple slaves are supported through selection with individual slave select lines. Here we will use one master with a single slave or one master with multiple slaves. Like if we compare the SPI serial communication with asynchronous UART, in UART there would be no control over the data. Here in SPI we can control the data bits using the clock signal, because UART is asynchronous communication. There won't be a clock signal, so thereby there we will use a extra start and stop bits for the data transfer. The advantages over synchronous communication is we will have separate data and clock signals. So the clock will be a oscillating signal. So they using the clock signal either at the falling edge or rising edge, the data can be specified. So here the speed is not a constraint, because the data signal and the clock signal are specified at a time. So serial communication protocol using synchronous is a better version than UART. UART is a asynchronous, so there we won't be using any clock signal. Internally, baud rate generator has an internal clock which generates the clock signals, whereas in SPI we'll use a clock signal and a data signal and no speed constraint. SPI can operate, like as discussed earlier, SPI can operate with a single master and with multiple slave devices. One unique feature is that the data can be transferred without any interruption, because the clock signal and data signal are transmitted at a time, and at a time master can send and at a time slave can send. So it is a full duplex. So as in UART, here also we'll use one stop bit, start bit and stop bit. One stop and stop conditions are also used. Devices communicating via SPI in a master-slave relationship. So here the master is called the controlling device, while slave is like which takes the instruction from the master. There is always only one master, but there can be one slave or multiple number of slaves. So here is the interface of the SPI. In SPI we'll have one chip select pin, S clock pin, master out slave input pin, master input slave output pin. So chip select will enable the operation, and S clock, the clock signal will be generated only by the master device. So S clock is from master to slave. Master out, slave in. So it is from master to slave. Master in, slave out is from slave to master. These are the interfaces. So as discussed, SPI is a synchronous communication protocol, and 1 bit of the data transfer in each clock cycle. So the speed is determined by the frequency of the clock signal. SPI communication is always initiated by master because clock is generated by master, since the master configures and generates the clock signal. Slave select. So the master can choose which slave it wants to communicate by setting the slaves. So like there can be a single slave or multiple slave. So based on that, that there will be single slave select or multiple slave selects. So this is the data transfer operation. So here we'll see the how it operates. So the clock signal will be generated. The clock signal will be generated by the master, and next the master switches the chip select into a low voltage. So chip select will be low. Then that activates the slave. The master sends the 1-bit data at a time to the master along with the master input slave output line. So the master reads the bits as they are received. If a response is needed, the slave returns the data 1 bit at a time to the master along with the master in slave out line. The master reads the bits as they are received. So what is this operation means? Here the master generates the clock signal. This clock signal is transferred to the slave, and from the slave the data bits or which are transferred or again transmitted to the master. So this is a full as discussed, this is a full duplex communication, as data transfer takes place from the transmitter to receiver, that is from master to slave, and from slave to master at the same bit rate. So it is a full duplex communication. So if we compare like with UART is asynchronous and SPI is synchronous. And if we compare SPI with I2C, whereas in I2C only like multiple masters can be interacted with the slave. Here only one master with number of slaves. So data transmission. So data transmission, as we have seen the before diagram, the data transmission like it takes place like between two shift registers. So the clock signal generates the bits and the bits are transferred like single bit transfer. One bit it will be transferred from master to slave. So this is master out, slave in, and the data received to the slave. So here the data will be transferred through a shift register. So the data bits are transferred from MSB bit to the LSB bit. So shift register will be there. Through it counts the bits and the bits will be transferred. And here like from the slave again like this, it will be coming from master, for master as input, the slave output will be transferred. So it is a full duplex communication. So on one edge of the clock, both master and slave shift out a bit and output a transmission line to the counterpart. On the next clock edge at each receiver, the bit is sampled. So here is the master code. How like the code will explain how the data will be transferred, how the clock will be generated using a FSM. Here is the slave. So today we'll discuss only about the slave module. In the slave, the data received should be again like transmitted to the master. We'll use a shift register and we'll transmit the bits from MSB to LSB. We'll use a always block for clock generation, and we'll use one always block for output, and one always block for next state. This is the test bench. So after executing, will instantiate the master and slave in a test bench, and then we'll pass the test cases. And so finally we will get the output. Here the data bits, the clock, first the clock is generated, and then we will generate the start and stop bits and master data. So the data is transmitted from master to slave, and again master generates the S clock signal. So like after completion M done, so master is completed the data transfer, and then it will receive the data one by one, like one bit it will receive, and then finally the completely it will receive the data from the slave to the master. Thank you.